Hello there, my name's Vince from My Mate Vince, and check this out. We have a DeWalt Leaf Blower here, cordless one, so it takes an 18-volt battery. Fortunately, I don't have any batteries, but I do have Milwaukee batteries down here. So I've ordered up an adapter that you can put on to this one to make it fit a DeWalt one from Amazon. But in the meantime, I'm just going to connect up my bench power supply, put 18 volts into it, and see why this isn't working. It looks brand new, yet it's supposed to be no power. So let's bring it over to the blue mat, put 18 volts into it, and let's see if it really is no power. Right, this shows 0 signs of use, so I'm just going to take this out, make it easier to work on. There we go. Now, it also comes with an end bit that I haven't got, which has some fancy name, and the idea is it's supposed to make it more powerful, I think, and you can scrape stubborn leaves and stuff with it, so quite a good idea. Now, I should have probably seen if I could fix it first before buying this adapter, but I'm thinking in the future I probably will be doing more and more tools of various descriptions, so it would be nice to have adapters so that my Milwaukee batteries can fit other brands. Now, on this one here, it's saying negative and positive, and I had a look online and it looks like the DeWalt batteries are also negative and positive in the same way there. So basically, I need to be putting positive to this one here and negative to this one here. So let's do that. I'll keep my hands well away from here. It doesn't look like there's any micro switch there, so I presume it's just going to work like that. Unless you do need, maybe you do need to plug it in. Let's try it to begin with. So I'm getting my bench power supply. Right, that should be 18 volts and it should be 1 amp. There we go, 17.9. Double check again. So it's going to go in that way. So we've got the negative this side. And we've got the positive this side. I'm just going to tap it. And let's see. Right, it's not drawing anything. And nothing's happening. Right, let's put the nozzly thing back on it, in case it does need to be connected to stop hands or something going in here. Don't think so though, I can't hear any micro switch. So this looks like it's faulty from manufacturer or shipping or something. Right, let's give that another go now. And positive up the top. Okay, let's see. No, nothing happening. And it's not drawing anything. And I think that's kind of hands-free. Cruise control. Okay, right. As far as I can see, it's not working. Maybe you do have to have a DeWalt battery plugged in because we do have other terminals here, but I'm not so sure. I think it should work as it is. So let's take it apart and see what we can see. Now, I'll save it now to save the comment section, but I don't agree with leaf blowers when you just blow them out onto the street because they're just going to go straight into somebody else's property. But in a garden like mine, it's all encased by walls and fences anyway. So basically, the idea is you would just blow all the leaves into the corner of your garden, making them easier to rake up. Or throwing them over the fence to next door, of course. Right, we have various different screws around the place. So lots of screws to undo. They're hex 2.5, so they're like Allen key screws, hex keys. And I need an actual Allen key for some of them rather than the screwdriver bit because of the depth. My screwdriver bit wouldn't go into it, but the Allen key does. Excellent, we're in. Brilliant. What is what? So we have the main power ones coming in. I mean, what's this thing here? What's this red thing here for? It's like a Wago. What? It's a Wago. It's some fancy Wago, but it's not a Wago. That's interesting. Why have they done that? Why wouldn't they just have the wire going through? How weird. Right, so goes through the Wago, continues on into another Wago here for the red, and then goes yellow into here. Looks like there's some weird capacitor type thing. So where's the black one go? So the black one goes straight down into the motor. And oh, this is how you turn it on. So 1 second now. So when that's here, is that allowed to? Is that going all the way down? Yes, it would be when you do that. Okay, well, I suppose we have to see if this is working first of all. So let's get our meter on continuity, because it's definitely not making a click. This should have speed control though. This should be speed control, but I'm thinking there'd be some sort of continuity. So we've got the yellow one, and would it be yellow and red? Let's try that. Yeah, so switch is working. Okay, yellow goes into here, so it should then go all the way down up to the battery contact through the Wago thing. So let's see if we have, I don't know which is positive, I forget. Well, I'll tell you what, let's not forget. Let's pretend we're plugging that in. So the positive is going to be the one near me. Red goes to here. Right, so red is getting there. Let's do negative. So negative goes into here. And then it's going to go into the motor. So red goes there. So then, if we go back onto the red here, we know it's going to here. So if I was to go into here and press the button, it should go to here, which it does. So we should have 18 volts at the motor. Oh, is it a motor problem? Now I'm wondering if this is slightly more intelligent. I'm wondering, because like for example with an LED flashlight, it's just using the outer two ones here, but I wonder, is this using the middle two? In which case then it might not work with the battery that I got from Amazon, you know, the battery topper, to convert my Milwaukee one, because it might need these other wires for some reason, which I'm not clear at the moment what they do. That switch at the bottom doesn't do anything. There's no electrical contact there. It's just a little retaining clip. We have a tiny bit of dust here. Right, well it looks like they go into this side up here. So let's take off this and see what we can see. Haha. Okay. Right. Well, I suppose first things first, we should be checking for some sort of continuity. I wonder, does this plug in here? Continuity on the wires. Ah, right, okay. They're soldered on there, interestingly. Right, well let's do continuity on here to here, and at least then we know the wires themselves are okay. They look fine. Interesting, they're all crossed. Right, they're all okay. Yellow's okay. And white's okay, and there's no short there. So the wires themselves are all right. Can I check the black one? This looks like it's moulded on in. Right, let's undo this and this. So we've got 3 little screws here. I wonder, would that take off the whole thing? No, it won't, because we're soldered on all these bits. There is a little bit of dust in here. I can see dust in there. So it must have worked for a short amount of time. I wonder, I'll tell you what I'm going to do. I'm going to undo this shroud here. I'm going to spin the fan, just in case it's gone, in case there's some weird dust or something on the contacts. I could just reach in and do it, but I want to feel it by hand. Right, see what it feels like. That feels completely normal. You know, it kind of does that clicking round as it goes because it's brushless. And it's not jammed. Feels lovely. I wonder if we were to spin it, whether we would see anything different on these points here. Let's go to resistance. Let me just see what it's reading now. So short, short, short. Now, if I was to spin that, so that is changing when I do that. Let's go on to another two. Okay, that's steady-ish. And again, that's changing, isn't it? Steady-ish. Massive differences. There's not much differences here though. I wonder, is that normal? Yeah, there is. Okay. There doesn't seem to be anything wrong as far as I can see initially. I think I'm going to put it back together just in case it was something to do with dust or dirt on something. Okay, here goes. I'm going to hold it here. Lean back a bit. Oh, there's nothing happening. So do we measure voltage here? Should we see if anything comes through? Don't really know how to fault find brushless motors. When I say don't really, haven't got a clue at all. Right, so there's no voltage getting there. No voltage getting there. Or do I have to go between a ground and that? Let me do this a second. We go in here. Well, here we go. No. Right, okay. Where does that red one go to? It's all sealed, isn't it? Thing is, I'm not 100% sure if we've got a contact there, so I'm just going to gently pierce just here and see if we have voltage. We do. So we definitely got voltage going into here. So we've proved there's a problem with the motor. Just going to go pierce on both of them ever so slightly. Yeah, so we have 18 volts going in. So there's going to be something on this board here. So now I have to unsolder the 3 points that I was measuring earlier, the ones that go down to the brushless motor. But that's easier said than done because they're very big and they suck up a lot of the heat of the soldering iron. But I'm flooding it with leaded solder and I'm doing my best to pry it up, but it really is a complete nightmare to undo. It's amazing how much heat this is drawing away. But if I was to use my hot air on it as well as a soldering iron, I'm just going to melt all the plastic around. It does probably take me a good 10 minutes or so to get this off, and there's plenty of burning going on while I'm getting it off. Yay! Hallelujah! We're in! Right, so I'm going to assume that the windings are okay because I'm getting some kind of reading. Will this give up its secrets? So, let's see now. Did this only lift off because it was warm? So we're going to have to do some cutting, aren't we? I hope I don't break anything now. I presume this is just a plastic case. There we go. Wow. Don't think I'm going to be able to fix this fella. Oh, hold on. So they are Oh, so they're soldered down there, okay. Soldered down on there. Let's see what's happening this side. Wonder, do we have more stuff this side? Yeah, oh dearie me, we do. Right, okay. Oh, hold on a minute. Oh no, I've just lifted two inductors or something off the board, haven't I? Oh, I thought they were the connections. They're not. They're the... I've lifted two capacitors, I think. Well, that's not really a problem. I can get them out. Well, it certainly is waterproof. It's just not very. It's not very friendly to fix. Okay, well, there's nothing else there. Apart from those two massive metal. Are they heat sinks for these chips? It looks like they are. Okay, well, I don't need to worry about anything else there. I think I can get to all the components. Yeah, look underneath each of them. They have massive heat sinks. Right, first of all, let's have a visual indication. I think we can all agree that this is not going to be something that can be fixed, I don't think. But let's have a little look in case we find a blown chip or component. Shorted cap be nice in this instance. Right, well, there's nothing blown there from what I can see. Let's have a look at this side. So these are all the same chip, 4C022. Yeah, okay, 1, 2, 3, 4, 5, 6. So are these 1, 2? How does it know where things are? If we're soldered into here. 1 second, I just want to have a look back on here. What's that? WVN. Where's the sort of Hall effect sensors? How does it know the location of this here? What's that? Don't know. I think I should get the flare cam. I think I should put it on, press the trigger, get the flare cam, and see if anything lights up. Maybe there's a shorted cap or something. I presume it's okay to turn on without the motor attached. You know what's going to save me a lot of time? I'm going to mark this up so I don't have to keep looking. So we're going to go on this way. Positive is here. I'm hoping now, the very fact we've got this here, do you know, I'm hoping that the seller didn't also use the same battery adapter as me. Imagine if there was nothing wrong with this. You know what I mean? Because why have we got this thing here? This must be reading the pins on here. Must be. Must be measuring temperature of the battery or something like that. It's not just a dumb tool. And all I'm doing is putting 18 volts in. I'm beginning to think now there might not be a problem with this. Maybe the customer sent it back because they didn't like it. Maybe it wasn't powerful enough. So now I bought that battery, I'm actually thinking that maybe I should go out and buy a DeWalt battery, even if I just get a weak one purely for testing. You know, a 2 amp one or something. Okay, not so sure now. Right, let's see if anything is getting warm. Right, there's no heat from there at all. Just my fingers, you can see. Let's try this side. And there's no heat from there. I want to know what these two are doing. Let me do a little bit of research into that. Maybe I need to short one to ground or something like that in order to get it to liven up. I'm now thinking there might not be a fault with this. Sorry guys, I can't believe I just did that. I got the FLIR cam out, I set it all up, I didn't press the trigger. Now there's still 18 volts going into the circuit board, so if there was a shorted cap it may still have shown up. But why on earth didn't I press the trigger? Because that would liven up more off the circuit. So massive apologies. I don't know what was going through my head. I think it's because at this point in the video I've come to the realization that I don't think there's anything wrong with this tool. I think it might be user error, or maybe the first person sent it back because they didn't like it. I'm thinking it's something to do with the yellow and white wires, and that's the reason why it's not working, because I'm putting 18 volts in, but these yellow and white wires have to communicate with the battery, maybe in order to liven up the tool. Because, think about it, on a leaf blower, it's going to be giving everything for the 5 or 10 minutes that the battery lasts. So maybe the tool can't just be a dumb motor. Maybe it has to communicate with the battery to make sure that the battery's not under stress, not heated up too much. Because although you're using it outside, it could still be a danger to the user. So I don't think this is just like my flashlight, which just works off a positive and a negative. I think this needs to communicate with the battery to say, hey, are you okay? Are you too hot? If you're okay, I'll continue working. If you're too hot, I'm going to stop working. But you know what? I know that I'm going to need a proper DeWalt battery unless this adapter does the conversion for me. Because if you have a look, something dumb like this light here, it's just got 2 pins. So I can run this from a bench power supply, no problem at all. But if you have a look here, we've got more, and it's not just populated. It's not just here. We've actually got a wire. There's no way a manufacturer would do that because it means it's going to cost money. And I've traced it down on here, which I will show you now. So each wire goes to a little transistor through resistors. So clearly it needs to read something in the battery of the DeWalt battery, some resistor or something, in order for it to work. So if you have a look here, if I go onto the white one, yeah, this is the one that goes to the 2 middle pins on here, the 2 middle ones, yeah. Also, can you see they're half the height, but clearly they're there for a reason. And if we go to here, it goes to the resistor, the transistor. Is it this one? There, that one there. Then it goes to that, through that resistor. Then it goes through that resistor to that test point there. So clearly that test point then goes on somewhere else. And if I go on to the yellow one, there. It goes to here, it goes to that point there, and it goes through that resistor onto this point here. So then it goes to that test point there. So that test point again is probably going to go to some kind of chip or something like that. So there's no way that that would be there if it's not doing anything. So I mean, maybe I could fool this by putting a resistor or something across it. But it's communicating with the battery, isn't it? So this tool is communicating with the battery. Ah, that's annoying. But still, it was interesting to see the inside of it. I'm going to now pick up the video the next day when the little adapter arrives from Amazon. We'll plug the Milwaukee battery into this and let's see if we have any life.
The next day.
My Amazon adapter has arrived. Well, okay, let's plug it in and let's see if it's made any difference. I'm just a bit concerned that it's not taking anything from here. It's purely taking the power from here. Yeah. So what I've done is I've balanced this back on here, but it's not soldered up. I just want to see if there is continuity though between the board and these bits. No. So I'm going to have to put a little bit of solder on each of them. I put it on the correct way because I've taken pictures, and also it only fits nicely on this way. Right, they seem to be connected. So now let's see, because I don't think there's anything wrong with this. We're in. Right, I'm going to hold this down in case it goes crazy. Whoa! Well, there we go. There we go. There's nothing wrong with it. Well, how do I feel about this? Well, obviously, it's a glorified teardown, which isn't good, so apologies for that. If I had the proper DeWalt or the adapter battery to begin with, then it would have just been working. But it was sold as faulty. I am actually partially pleased because I got this for, I think it was £45, I think I put the offer in that, or £50. And it's about £100 less than what they would be if I was to buy one. And I was umming and ahhing about buying one anyway after using my friend's Makita one. But then I went out and I raked my garden instead, and I thought, you know what, it's probably just as quick to rake. But I was tempted to buy one. So part of me is actually pleased, but it's just a shame because it's a boring video to watch, I think. But saying that, it's still interesting to see the inside of this. There's more to this video yet as well. Now, what's interesting is I was sure that this was no power, but after reading the listing again, I've now realised it says that it starts and stops immediately. But when I just tried it now, it was working fine, wasn't it? It didn't start and stop immediately. It worked with the trigger. So I'm putting this back together because as far as I can see, it's all working fine. To get the kind of rubberized plastic back on, I'm clamping it with, I've heated it up to begin with to make it a little supple, and now I'm clamping it with my pliers while heating it up everywhere. This will allow it to flow back onto the board again, and then I'm sealing up all the joints again with my hot air. Really, it's come out all right. Yes, it looks a little bit messy, but I think it's going to be just as waterproof as it was before. So I've put it all back together now, and we're going to bring it out to the garden. I'm going to show you it blowing some leaves around the place. Right, okay, so I definitely know it's not going to be balanced when I put the bigger battery on because it's already bottom heavy. Right, while I'm blowing the leaves around, I will shout out to my mate Vince Massive. The members of the Massive are KipDigital.com and Kip Hakes on YouTube, Max Rokotansky, Chris Seal, Felipe at MrKeeps.com, DJ VG, Pigsy, Anthony Dean, Russ Melanson, Shigate, Rickard Berglund, Soulweaver 555, Shamsa Al Sawadi, Stuart Park, Stephen from the Broken Past over on YouTube, and Lee Benz. So a massive thanks to each and every one of you. Okay, battery went flat after about 5 minutes, so now I'm back to raking. That is the pile there, air blower did, and this is the pile here that my rake has done. Now I'm going to have to use the rake to get that into the recycle bin anyway. So for me, the verdict's out. It's like one of those things, if somebody else is bouncing a basketball or tapping something, it drives you mad, but when you're the one bouncing the ball, it's fine, you could bounce it all day long, the sound doesn't irritate you. So when I'm doing the leaf blowing, it's brilliant. It feels nice having a powerful motor in your hand, I'm not going to lie. But to everybody else, you see, that sound is really irritating. And the thing is, it costs electricity, yeah? And it's going to be worse for the planet than you using a rake, and worse for yourself as well, because you're going to get a bit of fitness. I'm not sure, the jury is out for me. I don't know whether it's any quicker than a broom and a rake, but it is certainly more fun. And for those of you that are curious about how this little adapter fools the tool, well, from the bottom here, it's just straight through. So the positive is going to this side of the circuit board, which goes straight through to here, and the negative goes straight through again to the circuit board and through to here. And if you have a look on those middle two, this one here and this one here, what happens is we have got it goes from that one there, the one near the positive, it goes to the positive via its 103 resistor, so a 10,000 ohm resistor. And then from this one here, the one near the negative, it goes to the negative via 3,000 ohm resistor. And it goes to the positive, because it goes down here to here, via a 2,000 ohm resistor. I'll just show you that. So clearly the tool's looking for these resistors. Oh, well, this is fooling it into thinking it's the, I presume, the thermistor thing. for the heat of the battery. Right, so that's 10,000 ohms that side. And then if I go on this one here to here, we have 2,000 ohms, and this one here, it should be 3,000 ohms. So there you go. Very interesting.
Now, if you think that's interesting, prepare to have your mind blown. So remember, this was sold as works then shuts down immediately. Well, it does that when I use this massive battery here. So I went out and I bought a DeWalt battery. Now check this out. When I put the DeWalt battery in, it works perfectly. Okay? Trust me that it works perfectly. I've done the garden with it. When I use my good Milwaukee battery with the battery topper from Amazon, it works perfectly. You ready? Okay, again. Now watch. When I use the same battery topper with my massive Milwaukee battery, which outputs 18 volts, fine for my flashlight, I'll charge it up from my bench power supply, but it's got 40 insides where I can't actually, the battery management system's gone. I can't charge it up with the Milwaukee charger. Look what happens. Can you see there? Starts and stops immediately. But yet, if I start slowly, I can get it up to about 60% speed. There, bit more. Bit more, and now it will stop if I go more. Ready? There you go. So it will always work if you go slow, but not full. And it's not a problem with the trigger because I can't get it too full. Even if I go real slow, it will only get to there, and it will cut out, and I've still got all that to go on the trigger. And it's not a bad connection on the battery because I've wiggled it around the place. And now I thought, well, that's interesting. Clearly it must be something wrong with this. So I went to my bench power supply. My bench power supply will do 30 volts at 10 amps. And look what happens. And check this out, it gets even more interesting. I'm on my bench power supply. I've got it set to 19 volts and I've got the currents gone right up, and this will do 30 volts, 10 amps apparently. I've got it connected onto the battery adapter here in the right orientation, and it will also do the same thing. See? And if you have a look at the screen here, when I press it, sometimes it will go up to a high amps and drop straight back down again. Let's try it again. See there? It nearly went up to 7 amps. But yeah, if I do it a small amount, it will work. And then turn off when I go full. So strange. So now, isn't that really interesting? Why on earth, when all this is doing, this is the confusing bit for me, and if you could answer this down below, all this is doing is taking 18 volts. We only have two things here. Physically, there's nothing else there. There's only positive and negative. And if we come down to my multimeter here, it is 17.9 volts. It should work at 17.9 volts. So really, really odd. Along with the bench power supply as well. So if you could tell me in the comments section what it is in here that doesn't like the bench power supply and doesn't like this battery, but seems quite happy with this battery and this battery. Surely my bench power supply is putting out more than 2 amp hours. I would have thought. I mean, this must be putting out an absolute huge amount. I know it's 12 amp hours, but obviously the battery management system's gone. But yeah, really, really odd. And yet on this one, it will work every single time. So strange. Lots of questions to be answered in the comments section. So there we have it, the end of the November Fixathon. I thoroughly enjoyed that week of fixes there because most things I could get my head round, and any one of you could fix these items. A lot of them were just loose wires or something very straightforward once you had a look on the inside. So we were quite successful with the amount we fixed in the end. This one, is working for me, but I haven't done anything to fix. It's the same as it was when it was sold to me. Stapler can't be fixed. Some people did say check Power Tools, because that same setup will be in Power Tools. So maybe I might come across a gear in the future that will fix that. And everything else was really fixable. I've already given away a couple of items, the can opener and also the ring tyre inflator as well. So thoroughly enjoyed that there. The best thing for me, I think the most interesting by far, was the kettle. But I think the thing that I'm going to probably use the most, well, obviously the kettle will get used the most, but I think this one here will be the most fun for me. So yeah, really enjoyed it. Now the first thing to clear up is my meter. A lot of people said check the fuses on the inside, because remember I was getting a reading when I went onto amps, but not milliamps. Well, check this out. I presume this is going to be for amps because it's massive. You can hear continuity, but look here. No continuity! So I'm not going to get a reading on milliamps, am I? So I'm going to have to buy myself a new fuse. So it's well worth checking that on your multimeter, because if ages ago I had it on, maybe connected that up via voltage or something, that might have been enough to blow that one there. Also, a lot of people said, Vince, why am I not using the micro amp one here? I never even thought to use that. So I've got amps, milliamps and microamps, and there's going to be 1,000, I think, microamps in 1 milliamp. So if I was to go right the way round to here, then that surely should show something up. So yeah, it means that there was parts of this Fixathon that was irrelevant because this fuse was gone here. But still, a lesson to be learned, and for others to check their fuse as well. I've just taken it out and it tells me what it is. 200 milliamps, 250 volts. So I'm going to go onto eBay and get one. Another thing that people have been really interested in is the two switches. I thought it was to have one as a fail-safe, so the user wouldn't know if one switch fails, because when I often fix things, it can be the micro switch that has gone. But other people are saying no. Lots of people think it's to do with one to make it work, one to make it light up, but then as many people seem to think that one is for one direction, one is the other direction. So here we go, let's find out what's what. Now this one here is for the light, so lots of you are cheering, but you're not correct. But neither are the other ones correct. It seems to be a mixture of both. So I still haven't got an answer for you, because watch this. If I'm in this position, this works for the light. So you're going to be like, okay, Vince, clearly that's just for the light. If I do it again in that middle position, the light works. If I do this one, this works. But now watch. If your theory is correct, then this should work, shouldn't it? Yeah? But it doesn't. So basically, it's like this switch is dead. It's not. You have to press both of them. So in that position, press both of them. Light works, and then it goes round. Middle position, just the light works, and then this position, it goes the other direction. So really, in a way, everybody's correct and everybody's incorrect, because that one there is for the light, but at the same time, this one isn't just to allow power through. It's clearly linked to both of them, which is really interesting. That's what's great about the comment section, because people will give different opinions. So I actually still don't really know what's going on there. That is clearly wired directly to the light, but this has to go through this one to make it work, because that does nothing on its own in any position. There we go. But the main things people had questions on is why I cook my soup in a frying pan rather than a saucepan. A lot of people were saying it's because my wife's away, but no, it's because I find it super easy to clean, and also it heats up super quick. So don't knock it until you try it. We got a big area here, so the soup only goes so deep, so it's going to cook quickly. And then there's less washing up, because I always have a few slices of bread with my soup, or 2 to be precise, put it in the toaster, but only for about 45 seconds, just to get it a little bit warm, a little bit hard on the outside of the bread. And then what I do is I pour into my bowl, and then I get the bread and I just wipe it around like this, put that into the bowl, and then I've nearly got a clean frying pan. So yeah, give it a go. I swear you won't go back. So there we go. That was a very busy week for me with all the editing, but I've done it. I'm going to sit back with my nice glass of pink fizz and relax and enjoy myself. Thank you so much for watching, and I will see you all very soon. Take care.